We now want to look at the slopes that are associated with horizontal strata and what kind of topography is associated with this. So let's open up our photo album now to look at a few pictures. First of all, the question we need to ask ourselves is what type of topography is associated with horizontal strata? Here we see a picture of Tafelkop in the Karoo. And notice now that the cap rock represents the original feature, the resistant rock at the top, and then notice how this was progressively cut back. And so eventually we have this Tafelkop or tabletop mountain because erosion cut all the way back, removing all the other layers of the plateau so that now we have this feature. And notice that all the time as the erosion occurs, the height of the feature remains constant. Let's look at our next photograph. Here we're going to be looking at the feature that is now produced. This feature is known as a mesa or flat-topped hill. We can call it also a tabletop mountain. And notice the key feature of this, that the width is larger than the height. So that's how we know it's a mesa, in that the width is larger than the height. The next feature is what we see in Harrismith. So let's look at this photograph here in our album. And here we have the butte. And the butte is a feature that is smaller than the mesa. And so in other words, it's as a result of erosion. So there you see the cap rock, in this case, was quite a thick cap rock. Then it was removed. And then the river started cutting back. And so the slope was slowly denuded backwards until we have what we see today, this butte standing up there. Notice the top might have been less resistant rock, that's why it's got more of a rounded top. And can you see again, back wasting, reducing the plateau that originally was there, and then reducing the cap rock to create this feature known as a butte. And so can you see the difference then between a butte and a mesa is that with a butte, its height is larger than its width at the top. And so when we think about this, what did we notice? Let's look at an illustration here. So what we're seeing is there's the plateau, then rivers flow over it and erode it, and so the plateau gets broken down, and then eventually what do we end up having? Remnants of the plateau, and even smaller remnants which make up the mesa, and then the mesa is further reduced by back wasting and retreat of the slopes until eventually we get the butte. And so let's go back to Grand Canyon where we see beautiful features like these, and there you see the features that are produced with horizontal strata. So can you see all the layers are lying horizontal, and the resistant rock stands out as a cap rock. And notice there's a step-like feature to this geomorphology that we see here in the Grand Canyon because there are other resistant rock layers. Let's take a closer look at these resistant rock layers. So can you see there, you see the resistant rock layer, and they're lying horizontal. And notice how the layers in between that are less resistant are easily eroded, and that's how you get this step-like feature. Notice how in this picture how the Grand Canyon is shaped almost like into amphitheaters. And what creates that amphitheater shape? It's the rivers that are responsible for cutting back the back rock. And can you see now when we trace the rivers, notice how it flows down. So it's those rivers that are shaping that particular landscape. So it cuts it back almost in an arc-like shape. Now, notice these features have interesting slopes if we look at them from the side. So let's examine the slopes that are associated with topography that has horizontal layers. We start off with, first of all, right at the top. And notice right at the top we have a slope that is rounded, a concave slope, and that slope is called the crest. So you can see it's rounded right at the top, it's the crest. And then as you go further down the slope, you're going to get a very steep slope, a near vertical slope or a vertical slope, and that's called the cliff or the free face. When we move further down, we'll see that there's another slope which is more constant, more or less at a 45-degree angle, and that's the talus slope. And so it's got that constant angle as material then gets broken down from rolling down from the crest, broken down from the free face or cliff, it rolls down to create this sort of more gentle slope. And this constant slope then is where the debris occurs. And so sometimes it's called the debris slope because all the material that gets broken down from the cap rock comes to rest along this slope. And then finally, right at the end, we have a more gentle slope, and that's the pediment slope. And actually, when you look at this photograph, you'll see that the pediment slope builds up over time. You see it's actually building up from the left through to the right. And so what it then does is, eventually what can happen, if there's enough action by the river, it can actually build up the landscape. So the pediment can grow over time so that the landscape then gets widened out to be a gentle plain. So let's revise the different slope elements that we find with topography associated with horizontal strata. Remember, let's do a diagrammatic shape of it. There we have the shape. Right at the top, a concave slope, the crest. Then we get a steep slope, the cliff or free face. Then a constant slope, the talus. And finally a very gentle slope, the pediment. So that then concludes our examination of our photo book, looking at features associated with horizontal strata.